Hi, and we're back. Okay, so as I've said in the past video, we'll be talking about the applications of the ideal gas law. We're going to use the ideal gas law to calculate, or the ideal gas equation, to calculate for other quantities related to gases, such as the molar mass of a gas. Now, if we know the volume of a gas at fixed temperature and pressure, we can determine the molar mass of an unknown gas, or a volatile liquid. What's a volatile liquid? It's a liquid that easily evaporates. So that's a volatile liquid. Think of alcohol. Di ba yung alcohol kahit na ipahid mo lang sa kamay mo, madali siyang magda-dry compared to water or compared to oil. Hindi masyadong madaling mag-evaporate. So that is what a volatile liquid is. Now, how did we arrive at this equation? We started with PV is equal to nRT, the ideal gas equation. Now, N is the number of moles, right? Number of moles. And to get the number of moles, you must have the mass in grams all over the grams per mole. That's your molar mass, diba? Para makuha mo yung number of moles, kasi magiging grams times moles all over grams. And then crush out yung grams. Eh, siya moles na lang. So that's how you get your N, right? So magiging small m for the mass, maarte na m or a big M for the molar mass times RT. And then hinahanap natin is the molar mass. So we isolate the molar mass, M RT sa taas, P over PV sa baba. So here we are. It's quite easy, right? Now, you don't have to memorize how the derivation happened. You just need to look at the end result and just at least familiarize, ganun yun nangyari. Okay, it came from N equals mass over molar mass. Anyway, let's try to look at the example here. Give me one moment. Okay, I'm back. So we're given this example. An organic chemist isolates a colorless liquid from a petroleum sample. Now she places the liquid in a pre-weighed flask and puts the flask in boiling water, which vaporizes the liquid and fills the flask with gas. Now she closes the flask and then reweighs it. She obtains the following data. So meron kang volume ng flask, mass ng empty na flask, and the mass ng flask with the gas inside it. Pinapahanap sa atin ngayon is the molar mass of the gas. And anong gagawin natin? So let's use this equation. So we are looking for the molar mass, mass times RT over PV. Now, what mass is this? This should be the mass of a gas. Now, we have two given masses here. How do we get the mass of the gas? Look at the subscripts. If you have A plus B na mass, and then you're also given mass ng B. To get the mass of A, you just A plus B minus B, right? Para makuha mo yung mass ng A. So we do the same thing here. So mass of the gas is equal to this mass, 78.416 grams, minus that mass here, minus 77.834 grams. So that's 7, ayan, 78.416 minus 77.834. That's 0.0.50, 0.582 grams. So that's what we're gonna use. Equals one big fraction, 0.582 grams times the universal gas constant, 0.0821 liter ATM, all over mol K, times the temperature. Paano natin malalaman yung temperature? Sinabi dito, pre-weighed flask puts the flask in boiling water. Now, water boils at 100 degrees Celsius. Convert 100 degrees Celsius into Kelvin. So that's 373.15 Kelvin all over. All over. Sabihin natin, wala kasing binigay na temperature, right? Pressure, right? Now, for the purpose of this example, sabihin natin the pressure was 0.992 ATM. Now, if you encounter things like these in problem sets or the exam na feeling nyo kulang yung given, then let me know. Kasi baka nga na mali talaga ako. Hindi ko na sulat or I thought nalagay ko and then I deleted it. Or sometimes din talaga hindi din siya needed as a given. So, if you're in doubt, ask. Okay? So for now, for the example purposes of this example, let's put in 0.992 ATM and times the volume, which is the volume of the flask. Kasi nga, di ba, a gas expands to fill the volume of its container. So that's 213 ml. Convert that into liters, so it's 0.213 liters. Put that into a calculator. So that's 0.582 times 0.821, 0.0821 times 373.15 Kelvin all over 0.992 times 0.213. So it gives 84.4, 84.38, which is 84.4 if three significant figures. Okay? Anong unit niya? Now, let me use a different color. Liters, crushed out. ATM, crushed out. Kelvin, crushed out. You're left with grams over mole. So, grams per mole. Diba that's the unit for molar mass? So now you have the molar mass of the gas. That's it, right? So that's how you use an ideal gas equation to calculate for the molar mass. You just need to make sure that you have all the components that you need in the correct units. So if it's not in SI units, then convert it into SI units, okay? Okay. Now let's look at applications of the ideal gas law in calculating for the density of a gas. Kanina, we already calculated for the molar mass. So dito na tayo mag-start. Now if we have PV is equal to M, big M, times RT, diba? Density is mass over volume. So let's isolate that one. So M over V is equal to P times molar mass over RT. Transpose lang. This went up and then these went down. These went down as well. Medyo convoluted, but well, of course, math needs practice. So, transposing lang naman yan. From this equation, di ba, density is equal to pressure times molar mass over the universal gas constant times temperature. We can now see here that the density of a gas is proportional to its molar mass. Right? Because if nasa numerator, that's proportional. And then pag nasa denominator, on the other side of the equation, on the other side of the equation, then it's inversely proportional. So, directly proportional to its molar mass, inversely proportional to the temperature, and directly proportional to pressure. Now, what does that mean? If your molar mass increases, mag-increase din yung density. If yung pressure increases, mag-increase din yung density. If your temperature increases, mag-decrease liliit yung density. Kabaliktaran yung mangyayari because it's inversely proportional. Now, let's look at problems that involve calculation for density of a gas. A, a chemical engineer uses waste carbon dioxide from a manufacturing process known as a blowing agent in the production of polystyrene. Polystyrene is your styrofoam. Find the density in grams per liter of carbon dioxide and the number of molecules per liter at A, STP, and then B, and room conditions. So we're given a total of four things to solve. So at STP in terms of grams per liter and at STP for number of molecules per liter. Let me go back to the red pen. Red. There we go. Okay, so I'm gonna show you how to solve for these required quantities for letter A. For the conditions on letter B, you can just do it on your own. Now, STP is 0 degrees Celsius and 1 atm, diba? This is equal to 273.15 Kelvin. Now, density is equal to pressure times molar mass all over universal gas constant times temperature. What's our pressure? It's 1 atm. What's our molar mass? Molar mass ng CO2, that's 12.01 CO2 yan ha, plus 2 times 16.00 grams per mole. So that's a total of 44.01 grams per mole, right? Because 32 plus 12, 32 plus 12.01, that's 44.01. And then universal gas constant, and your temperature, 273.15 Kelvin. Put that all into a calculator. So that's 1 times, nilalagay pa talaga yung 1 ni ma'am, no? But just to show you guys. Equals 1.96. Three significant figures, right? Hindi natin isasali yung 0 degrees Celsius ha. Hindi pwedeng one significant figure lang, tapos calculate ka ng ganyan. Because it becomes 2 grams per liter, and that's very big discrepancy yung 0.04. Masyadong malaking discrepancy yan. So, check the units. ATM, crushed out. K, crushed out. Moles, crushed out. So, we're left with grams per liter. So, that's well and good. Now, let's do it for STP, molecules per liter. Pwedeng dito na tayo mag-start yung natira sa calculator natin. So, from 1.96 grams per liter, convert natin siya into molecules per liter. Ganun na lang natin para mas madali. So 1.96, let me write that a little better. So density is equal to 1.96 grams per liter. Yung grams lang naman kailangan natin i-change into molecules, di ba? So that's 44.01 grams molar mass per 1 mole of CO2. And then 1 mole of CO2 is equal to 6.022 times 10 to the 23 molecules. Molecules. Diba? Remember your Avogadro's number? Diba? If you remember that, then very good. That's from your chapter on stoichiometry. So crash out, crash, crash, crash. So you're left with molecules per liter. Put that in your calculator. So that's 1.96 times 6.022 times 10 to the 23 all over 44.01. ko ba? Okay. That's 6, no. That's 2.68 times 10 to the 22 molecules per liter. Okay? So the answer to letter B will be in the reading material that I gave you accompanying the chapter on gases. It's also around here. So you can do it on your own and then check later if you did the right process and if you got the right answer. Now, there's another thing that made Gale Lussac so prominent when talking about gas laws. It's this law of combining volumes. Siya yung pinaka-main proponent nito. It says here that if reactants and products are involved in stoichiometric calculations are all gases, sometimes we can just use a particularly simple approach. Now consider the reaction. Meron kang dalawang NO, isang mole ng oxygen gas, it can result to 2 moles of NO2. So this is our chemical equation, and then we're showing it in terms of moles. Now, suppose that the gases are compared at the same temperature and pressure under these conditions. 1 mole of gas occupies a particular volume, V, and 2 moles of gas is 2V, 3 moles is 3V, so on and so forth. So ito yung equation natin in terms of volume. Do you see? Pareho silang ano, di ba? If we divide those, if we divide this equation by this equation, matitira na lang, I'm sorry, if we divide, ito lang pala, if we divide both sides by V, then you have 2 liters NO, 1 liter O2, 2 liters NO2. Yung nangyari is the volume ratio ng mga gases consumed pareho lang dun sa mole ratio. Kunin ko yung mga sinulat ko walang kwenta. Ito, di ba? 2 moles, 2 liters. 1 mole, 1 liter. 2 moles, 2 liters. Again, that's if it's compared at the same temperature and pressure, and if the reactants and the products are gases. Walang solids, walang liquids, ha? So if it's all gases, then we can do this approach. So this is Gay-Lussac's law of combining volumes. So again, we have Charles' law, we have Boyle's law, we have Charles and Gay-Lussac's law, we have Monton's law, Avogadro's law, ideal gas law, and Gay-Lussac's law of combining volumes. Now, we have another law that we're going to look at here. The simple and ideal gas laws, it holds true, yung mga sinabi ko kanina mga gas laws, it holds true for virtually any gas under ordinary conditions, whether it's a pure gas or a mixture of gases, of air. Because, let's review dun sa ating properties of gases. Gases can mix homogeneously from a solution in any proportion, and then each gas in a mixture behaves as if it's the only gas present. So walang reaction na nangyayari, then it will behave as if it's the only girl in the world. It's the only gas in the mixture. Wala siya ibang kasama. Now, following those observations, John Dalton made some experiments and has observed that kung i-measure niya yung pressure ng water vapor, tapos i-measure niya din yung pressure ng dry air, ipag-add niya yung dalawa, yung total air pressure is exactly the same as humid air. Okay? So, additive pala, pwede palang ma-add yung mga pressures ng gases. Yun yung na-realize niya. So, in a mixture of unreacting gases, so this is an important tidbit here, unreacting gases, the total pressure is the sum of the partial pressures of the individual gases. So, if you have the P total component gases, i-add mo lang sila, you will have literal the total. Wala ka nang ibang gagawin because additive yung pressures ng unreactive gases. If the total pressure is due to the total number of moles, then the partial pressure of gas A is the total pressure multiplied by the mole fraction of A, which is XA. Ano daw yun? So, di ba, each component in a mixture, mag-contribute siya ng a fraction ng total number of moles. Di ba? Kasi if you have PO2, PNO, PCH4, it will have, di ba, ito yung mga total pressures nila. Then since they exist, that's, well, particles, they will also contribute as a few number of moles dun sa total moles. Let's say, for example, we have T moles or total moles. So we also have, bakit T yung malaki? Moles na total. So we will have moles of O2 and then moles na galing sa NO and then moles na galing sa CH4, right? So these portions are called mole fractions of the component. So this is the mole fraction of O2, this is the mole fraction of NO, so on and so forth. Diba, remember natin doon sa mass relationships natin na section, na topic, the sum of the mole fractions, so the mole fraction is the partial or the number of moles of a component, moles of the component over the total moles. Diba yan? Total moles of the compound. Diba yan yung mole fraction? And then, if you add all these mole fraction, kasi fraction nga, it should be equal to 1. Diba? So, may 1/2 ba ng mole fraction, may 1/4, and then may 1/8, and another 1/8. Diba? Yan equal to 1. So, the sum of the mole components, mole fractions must be equal to 1. And if it's expressed in terms of percentage, then the sum must be equal to 100%. Or else, may missing ka na component na hindi mo na-calculate. Okay? Now, if the total pressure, again, is the total number of moles, yung partial pressure ng gas A is equal to the total pressure multiplied by the mole fraction of A. So, ito yung ibig niya sabihin. Makukuha natin yung partial pressure ng component if we have the mole fraction of the component, ipa-plus lang natin, times pala dapat yan. Ito times natin doon sa total pressure. Ganun lang. And then, of course, itong mga pressures na to, makukuha natin yan from the ideal gas law. Or given, diba? Pwede din yung N, yung number of moles. Ito, pwede natin makuha from ideal gas law. Ideal gas, ideal gas, ideal gas, ideal gas, ideal gas. Diba? Or pwede din given. As long as we know that, we notice that yung ratio ng mga moles, ratio ng pressures, ratio ng volumes, this would be equal to the mole fraction of that particular component. Now let's look at this problem right here. In a study of oxygen gas, a physiologist prepares an atmosphere consisting of 79 mole percent N2, 17 mole percent O2, 4.0 mole percent O2, that's oxygen 18, so it's an isotope. The total pressure is 0.75 atm. Calculate the mole fraction and the partial pressure of oxygen 18 in this pressure. So itong 0.75 atm. Now, how do we calculate again for mole fraction? That's partial over total, right? Binigay sa atin na partial is 4.0 mole percent. Again, if naka-express in percentage, your total must be 100%. So you just divide that, you will get 0.040. Ito yung mole fraction mo. And then, since we already have the mole fraction, we can calculate now the partial pressures. So that's X times P total, di ba? So that's 0.040 times the pressure total is given as 0.75 atm. Then that's just 0.030 atm. It's quite easy, no? No? Right. So I think I already gave or I'll be giving a set of problem na mga na-solve na. Try to see if my problem that uses Dalton's partial pressures, and if not, then you can message me. I think I'm not sure kasi if nilagyan ko, but if not, then message me through the email, through the group chat, and then I can send you an example with a solution. Now let's see. 0.30. Okay, let's see this example here. Solid lithium hydroxide is used to scrub carbon dioxide from the air in spacecraft and submarines. It reacts with the carbon dioxide to produce lithium carbonate and water. What volume of carbon dioxide at 23 degrees Celsius and 17716 torr can be removed by reaction of 395 grams of lithium hydroxide? Now, carbon dioxide is a gas that is harmful to humans, and spacecrafts and submarines cannot exactly open their windows to ventilate, di ba? So they had to find a way to get carbon dioxide out of the air na ma-breathe in ng mga staff ng crew, and then that's how they recycle the air that they breathe, right? So they get solid lithium hydroxide to trap the carbon dioxide that is in the air. Kasi hindi kasi lahat magagamit ng plants if there are plants in the spacecraft or submarines. So, if we're given this problem right here, lithium hydroxide reacts with carbon dioxide to produce lithium carbonate and water. What volume of carbon dioxide at this given mga measurements can be removed by the reaction of 395 grams of lithium hydroxide? So this involves a reaction. If problems involve a reaction, we need our chemical equation. So that's lithium hydroxide reacts with carbon dioxide. That gives us lithium carbonate. So if we remember from nomenclature, Li plus yung lithium, carbonate is CO3 2 minus. So since they're ionic, i-crossover mo lang sila. So you will have Li2 CO3 plus water, that's H2O. Now let's look at their balance. They're not. So Li, dapat dalawa. Now let's double check. Dalawa dito sa left, dalawa sa right. Carbon, that's isa sa left, isa sa right. Oxygen, that's 2 plus 2 and 3 plus 1. Tapos hydrogen, that's 1 times 2. Diba? 1 times 2 is equal to 2. And then dito, dalawa. So now it's balanced. So now that we have our balanced equation, we can look at what's being asked. So volume of CO2 from the reaction of 395 grams of lithium hydroxide. So ina-assume na niya na, where is it? What's here? 0. Ang pangit ng kulay. Okay. So ayun na. Everything lithium hydroxide, carbon dioxide, lithium carbonate, and water. Now, what we're looking for is volume ng CO2 given tayo ng 395 grams of lithium carbonate. Now, we are not given this, di ba? Kasi hindi gas yung lithium carbonate, lithium hydroxide. Sorry. Solid yung lithium hydroxide. So, we are not gonna start here sa flowchart. We're gonna start somewhere here. Because grams convert mo into moles, diba? But not necessarily gas. And then we'll use the molar ratio from the balance equation to get the moles of the second compound. And then the second compound, convert natin kung ano yung quantity na hinahanap. In this case, volume. So, roadmap, grams or mass. Mass papuntang moles, grams, LiOH. Papunta tayong mole, LiOH. Tapos, convert natin into moles, CO2. Tapos, convert natin into volume, CO2. Yan yung gagawin natin. Okay? So, volume CO2 yan. Let's start with 395 grams of lithium hydroxide. How do we convert that into moles lithium hydroxide? We need molar mass. Now, what's the molar mass of lithium hydroxide? So, molar mass of lithium hydroxide is equal to 6.94 grams per mole plus 16.00 grams per mole plus 1.008 grams per mole. That is equal, wait, calculator. Where's my calculator? 6.94 plus 16 plus 1.008 is 23.948 grams per mole. So 23.948 grams per mole times, convert natin yung moles and moles LiOH into moles carbon dioxide using molar ratio. So for every 2 lithium hydroxide, we will use 1 carbon dioxide. So 2 moles LiOH, 1 mole CO2. And then, convert na natin yung mole CO2. Kunin na natin yung mole CO2. N pa pala. So, kunin na natin yan. That's 395 all over yung molar mass ng lithium hydroxide times 2. So that's 8.247 moles of carbon dioxide. And then let's use the ideal gas law. Now the ideal gas law is PV is equal to nRT. We're trying to solve for volume, so that's nRT over P. So number of moles, that's 8.247 moles of CO2 times 0.0821 times temperature 23 degrees Celsius plus 273.15 Kelvin all over pressure, which is 716 torr. Convert to ATM, that's 760 torr per 1 mole. Gives you a total of 716 divided by 760. So that's 212.84. Let's reduce that to 3 significant figures, 213. Okay. Others would reduce it to 2 significant figures because of this right here. So sometimes it will be just 2.1 times 10 to the 2, right? Because that's 210. But I don't really prescribe to doing that. I wouldn't prefer doing that because mas ano kasi siya, 'di ba? Mas exact number na kasi yung 213. Okay, oh, there we go. It's 213. Right? Now, I have this extra problem right here. Just you can try to solve it on your own. The answer is in the reading material anyway. So, just a hint, it will be using limiting reactants. Okay? So, let's try to refresh And let's not forget the chapter on stoichiometry. Okay, so I'll be cutting the video here, and I'll come back with the very last bit, which is diffusion and effusion. Okay, I'll see you in a moment.